Notice that 36, which is 4 times 9, is the factorization of 36 into powers of prime numbers. A number is divisible by 36 exactly when it is both divisible by 4 and divisible by 9. The important point here is that the highest common factor, some people say greatest common divisor, of 4 and 9 is 1. For example, 4 and 6 both divide 12, but 4 times 6 does not divide 12. The reason for this failure is that the highest common factor of 4 and 6, the GCD of 4 and 6, is 2, which is bigger than 1. First, we focus on divisibility by 4. There is a neat test for divisibility by 4. A number is divisible by 4 precisely when the number formed from its final 2 digits is divisible by 4. As far as the markers of JMO are concerned, you don't have to justify that this test works, but we will do that. You must, of course, clearly explain any divisibility test that you use. Examples include 232, 1004, and 10,000. In the first case, 32 is divisible by 4. In the second case, we have to drop the initial 0 from 04 and note that 4, which is 1 times 4, is divisible by 4. And in the third case, we regard 00 as 0. Note that 0 is divisible by all numbers. For example, it is divisible by 2024 because 0 is 0 times 2024. The reason that this works is, for example, that 123,456 is 123,400 plus 56. Now, 123,400 is a multiple of 100 and so is divisible by 4. Therefore, 123,456 is divisible by 4 if and only if 56 is divisible by 4. And it is. Our numbers only involve the digits 0 and 1, so to be divisible by 4 they must end in 00, and then they will be divisible by 4. There is a test for divisibility by 9. The sum of the digits of a number and the number itself leave the same remainder on division by 9. This test is so well known that you don't have to justify it in JMO, but we will do that. For example, 123,456 leaves the remainder 3 on division by 9, and so does the sum 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. The sum of the digits of a number is often called its digit sum. This means that you can tell if a number is divisible by 9 by testing if its digit sum is divisible by 9, because being divisible by 9 is the same as leaving remainder 0 on division by 9. So you can test for divisibility by 9 by testing the digit sum for divisibility by 9. Let's see why this works by using an example, 2024. Now 2024 is 2 times 1,000 plus 2 times 10 plus 4. And that's 2 times 999 plus 2 times 9 plus 2 plus 2 plus 4. Now 999 and 9 are divisible by 9. So the remainder when you divide 2024 by 9 is the same as when you divide the digit sum 8 by 9. And of course that is just 8. Consider the properties of a number which consists of zeros and ones and is divisible by 36. Such an integer must contain at least one 1 in its representation because it is positive. It must end 00 because it is divisible by 4. It must have digit sum that is a multiple of 9, so it must involve at least 9 ones. Therefore, every positive integer which uses only the digits 0 and 1 and is divisible by 36 must have at least 11 digits. The only 11-digit number made from zeros and ones that obeys these conditions, 11, 111, 111, 100, that is 11,111,111,100. It passes the test for divisibility by 4 and 9, so that is the answer. Here are a couple of extension problems for you to consider. How many positive numbers made only from zeros and ones are divisible by 36 and have 20 digits? The second problem, what is the smallest number made only from zeros, ones and twos, which is divisible by 36? If you can solve those, then you could make up some similar problems for yourself.